When I first started learning machine learning, I thought I had to master everything. Neural networks, deep learning, clustering, reinforcement learning. It was a lot. But over time, I realized something powerful. You don't need to learn 100 models, you just need 7. These 7 models show up everywhere, in real-world projects, in job interviews, in Kaggle competitions, and most importantly, they teach you how machine learning actually works. So today, I'll walk you through the 7 essential ML models every beginner should know. We'll cover what they do, when to use them, their pros and cons, and why they matter. Let's dive in. Logistic regression is the model to start with for one big reason. It's simple, and it works. Use it when you're predicting yes or no outcomes. Examples: will this customer buy or not? Will an email be spam or not? How it works: it takes your data and estimates the probability of belonging to a category. If it's more than 50%, we say yes. Less than 50%? No. Pros: easy to implement and interpret. Fast training, even on large datasets. Great for understanding the impact of each feature. Cons: only works well for linear relationships. Struggles with complex patterns. Not ideal for multi-class problems without modification. Why choose this model? It teaches you how machines convert data into probabilities, a core concept in ML. Next up is linear regression, another classic. But this one's about predicting numbers, not categories. Use it when you're predicting continuous outcomes. Examples: predicting house prices, estimating sales or temperature, forecasting trends over time. How it works: it draws a straight line through your data, one that best fits all the points. You feed it a new data point, and it tells you the predicted value on that line. Pros: super fast and efficient. Interpretable. You can see the effect of each variable. A great starting point for regression problems. Cons: assumes a straight line, linear relationship. Sensitive to outliers. Can underperform if relationships are complex. Why choose this model? It builds your intuition for how ML models fit data and make predictions, crucial for understanding all future models. Now we move to models that mimic human decision-making. Use it when you need interpretable logic or decisions based on rules. Examples: classifying customers into groups, diagnosing medical conditions. Any task where you want a clear decision path. How it works: it splits your data into smaller groups by asking yes or no questions. Like, is age greater than 30? Is income greater than $50,000? Pros: easy to understand and visualize. Works with both numbers and categories, no need to scale or normalize data. Cons: prone to overfitting. Small changes in data can change the entire tree, not very accurate alone. Why choose this model? It helps you see how models think and make decisions. It's one of the most intuitive algorithms in ML. If decision trees are powerful but fragile, random forests are the solution. Use it when you want high accuracy with less overfitting. Some examples include loan default prediction, fraud detection, and customer churn modeling. So, how does it work? Instead of one tree, it builds hundreds. Each one learns a slightly different view of the data. When it's time to predict, they vote on the result. Now let's talk about the pros. Random forests offer high accuracy, reduce overfitting, and handle missing data well. But there are cons too. They are slower to train than a single tree and less interpretable than individual trees. Plus, large models can use a lot of memory. So, why choose this model? It shows you the power of ensemble learning, combining multiple models to improve results. Support vector machines sound intimidating, but they're very effective for classification. Use it when you have a clean dataset and need clear boundaries. Examples include image classification, handwriting recognition, and bioinformatics. So, how does it work? SVM tries to draw the best possible boundary or hyperplane between two classes, maximizing the margin between them. Now let's talk about the pros. It offers high performance on complex datasets, works well in high-dimensional spaces, and is effective when there's a clear margin. But there are some cons too. It can be slower on large datasets, is sensitive to noise, and is harder to tune. So why choose this model? It teaches you how machine learning handles boundaries, margins, and kernel tricks. Advanced but fundamental ideas. KNN is one of the simplest models, and one of the most powerful for quick insights. Use it when you want easy classification or quick recommendation systems. Examples include recommending movies or products, identifying similar users, and predicting based on neighborhood behavior. How does it work? It looks at the k nearest data points and predicts based on what they are. If most nearby points are yes, yours probably is too. The pros? No training needed. Just store the data. It's simple and intuitive and flexible for classification or regression. The cons? It's slow with large data sets, doesn't work well with irrelevant features, and struggles in high dimensions. Why choose this model? It helps you understand how distance, similarity, and neighbor-based reasoning work in machine learning. Neural networks power modern AI, but don't worry, we're starting small. Use it when you need flexibility and are dealing with complex data. Examples include image recognition, voice assistance, and predictive text. How does it work? Neural networks are made of layers. Each layer transforms the input slightly. Over time, the network learns complex patterns from data. The pros? It handles large and complex data sets, powers deep learning tasks, and learns features automatically. The cons? It's harder to interpret, requires lots of data and tuning, and is slower to train. Why choose this model? It introduces you to deep learning and how machines learn by adjusting internal weights, just like the brain adjusts synapses. Let's recap the 7 essential ML models you should start with. Logistic regression, for yes, no predictions. Linear regression, for predicting numbers. Decision tree, for simple, interpretable decisions. Random forest, for robust accuracy. SVM, for clear boundaries. KNN, for neighbor-based reasoning and neural networks. For deep, flexible learning. You don't need to master every model right now. Just pick one, try it on real data, and build your intuition. If this video helped clarify your machine learning journey, smash that like button. Subscribe for more beginner-friendly ML tutorials and drop a comment below. Which model are you starting with? Thanks for watching, and keep learning.